After many years of working on and building engines like the NSR 400 motor you see here, I decided it was time to design and build my very own. One thing became clear, that I would really need to learn how to cast metal in order to turn these designs into something real. PLA casting is taking your 3D printed part, covering it in plaster, burning the PLA out, and then, well, just pouring the aluminium in. Sounds pretty simple. Unfortunately, there are some little drawbacks that I found. This was my first attempt at a PLA burnout plastic cast, and as you can see, it looks nothing like a cylinder head. The biggest problem that we kind of had was probably the PLA not burning out completely, and having just the basic tools of a little desktop oven and a little furnace. I don't think I could have achieved the proper temperature ramps and such to get all the PLA out. The second part is obviously the aluminium used. Now this was just melted aluminium cans plus some scrap aluminium I had lying around, throw it all in the pot and melt it up. This obviously had different cooling rates, which you can see caused some issues around the top here, and also flow into these more narrower journals and walls were just, it was just non-existent. Getting the plaster out of here, out of a complex shape at the end of it, it was also quite challenging, and so that meant that that was probably not the easiest way given the tools that I had. The next attempt was to do a wax loss casting. Now, taking your same 3D printed PLA part, you then create a silicon negative of that part, which looks something like this. And you fill it with wax, and when it comes apart, you will then have your wax part that you now want to go through the same process of, coating it all in plaster and then melting the wax out, and then obviously casting the part. Now with this particular one, as you can see, we had some similar issues. We got a much better shape, so you can see the barrel at the bottom here was much cleaner, but the aluminium again used was cooling, it looked to be not quite cooling at a uniform rate. We ended up with some rather large voids over here, and again, trying to get this plaster out of here was almost impossible. So that was kind of one of the better versions at the initial, probably my third cast ever that I attempted, and that was moderately successful, but not as successful as I would like. So lost foam casting seemed to be the one that works the best. Once I'd got my little CNC machine built and set up and working correctly, I was able to make some quite nice foam inserts and molds that look like this, and that seemed to be pretty much the easiest way to make a cast. So something simple like this with like sort of a flat side and then a side with a lot of details in it tend to cast very easily. Now this is only half of one of the things that were cast, because I cut this side off and reused the aluminium because I was running out. But one of the big things with this is I went to a car wheel, so using a mag wheel as the aluminium source, which seemed to flow a lot better. Also machined quite nicely once you're machining these flat surfaces. And this was my first attempt at a lost foam cast, and as you can see, like, most of the details came out really well. There was obviously just a little bit of depth in this one particular journal. That was just because the foam was not cut quite right there, and that was just a problem with the model. But in other places, it seemed to flow very well. It got a little bit towards the edge, got a little bit of pitting in there, as you can see. But other than that, it came out very well, and the machining on the little mini mill was amazing. So I decided to go away from the 4-cylinder and the 2-cylinder. So these were the next two casts that came out. Now these have all been machined on the inside, but they came out within spec except for this one little section here. And then the faces were machined and drilled. This bit here you can see didn't flow quite well, but it needs to have another 2 or 3 mils taken off. And yeah, so both parts came out. This part came out so nice when it came out of the mold. Like you could see all the the cut lines and stuff from the CNC, but all the bits and pieces came out really nice. The only issue with this one is I try to go too small for the 2-cylinder, and so on the model I'd seen all the holes and there was enough gap and enough spacing and enough clearance and on most of them. But when you come to actually doing it and you're trying to sort of clearance out the head for the holes, you can see that there's been a couple of spaces, particularly over here, where if I put my hand behind it, you can probably see the hole there. Going and looking at the model, when I actually work out what head clearance I needed, there was only like 0.2 of a mil worth of aluminium in there. So that obviously, with a bit of imprecise machining to get the crank to rotate nicely in here, that was just not enough aluminium, and it just blew a hole straight through it. So I may end up looking at fixing these, or I may melt them down. The model's obviously moved on since this iteration. So going back to a 2-cylinder, but now we're going back to a 2-cylinder that are connected by gears, very much like the V4 was going to be. This is one of the cutouts that I've got for one of the sides, and as you can see, just basically running a side carb, and we'll be running a side carb for these. Now, this cut out very, very well. The foam was, exactly as the model was. It just went a little bit deep in this one corner, but I mean, there's still enough thickness on the back to quite make a good shell of the motor. And one of the big things though is I decided to shell most of this model out. So, clearance all the space out here, leave some meat on it for the head bolts to go in. But unfortunately with the shelling, it meant that there was some quite thin walls, but also the flow path for the aluminium to get to all the spaces nicely wasn't very well designed. And so I thought I would attempt to put the flow path on the back of the mold. And I thought if I made a big enough flow path here that just went through the mold, it would all flow down with gravity to the bottom, to the front face of the mold over here. And this is where we ended up. So as you can see on the back, I had like a multi sort of triangular pouring flow path, and it kind of worked and kind of didn't. So we obviously got quite good definition with all the shapes that we had cut out, but the problem that we had, and what I didn't realize, is that there was the holes for the crankshafts and the hole for the center. And what happened was that the aluminium, once it gone through that hole, it just started filling up or pushing against the sand that was in here, and basically filled up this cavity, and it's got some jib behind it, and then it filled up all these cavities here. Now, what that also meant was that the flow path was going in through the back, down this front edge, and then trying to push up this way into this edge. And as you can see, it just didn't get there. There just wasn't enough pressure to basically do a U from here through these thin walls and then up to this thin wall here. There just wasn't enough pressure to do that, and also probably not enough time for the aluminium to get there. Even though I left it for about an hour in the mold, like this just couldn't get there fast enough before there was cooling on these really thin parts to like stop the flow and stop it going through here. So this is a failed one. It's not salvageable, just not great. But what I am going to do is I will be the next stage, and that's where we're at the moment, is going to be taking this mold and recutting new ones, basically not shelling out any of this. So it'll be a solid cast, so it'll be quite a bit heavier. I should have enough aluminium for it. The other thing I'm also going to do is fill it from the wide side on the top edge here. So basically, because this will all be filled in, there'll be this nice solid journal down the middle to fill in this part and this part. And then this will be a nice solid journal down these edges here, so it can just flow straight down here. And I think that besides the fact that cleaning off a pouring top out of a thing that's only 35mm wide will be easier, it'll also mean that there will be a lot less chance of there being any issues with these features when the aluminium goes through. And because it's all flowing through thick channels and journals, there will also not be an issue with cooling before the aluminium fills the entire mold. In the next video, I will look to go into my CNC a little bit more and how it is set up, and we will look to cut the foam insert for the next iteration of the casting process. See you then.